My name is Madeline. I go by Maddie Schreiber, and I am a professor in the Geosciences department at Virginia Tech. So I'm going to talk a little bit about my research and travels and sort of my path in geohydrology. My STEM story, I guess, started in high school. I was always interested in science, but when I went to college, I started as a history major, and my goal was to go to law school. But I ended up taking a geology class. It was a requirement for my minor in environmental studies. And so as I took that class, I fell in love with geology, and I changed my major to get a BA in geology. But some other experiences in doing field work and in undergraduate research really got me super interested in geosciences. And I switched to a bachelor's of science degree in my senior year, and that's what I graduated with. So after college, I worked in environmental consulting for 2 years in Boston. And in that job, I mostly worked at contaminated sites that had water and soil with contamination, mostly at Superfund sites in New England. So these are big toxic waste sites that are managed by the Environmental Protection Agency. During that time, I did a ton of field work. I learned a lot, did quite a bit of report writing. And it also piqued my interest in the issue of water contamination. After that, I actually took a little bit of a turn in my career path, and I decided to volunteer for the Frontier Nursing Service in Kentucky, which was actually the first midwifery school in the US. And that was a key personal experience for me, not related to geology, but just a key personal experience. And after that, I did decide to go to graduate school. I started in a Master's of Science program in hydrogeology. And during that time, I realized I enjoyed teaching. And so I decided to continue for a PhD. And so the key experiences during my graduate school life were doing a lot of field work, doing independent research. I did a summer internship with the Department of Energy, and also teaching, which ended up being a really important passion for me, which I didn't realize that I was going to like teaching until I did it. And so that leads me to the faculty position at Virginia Tech. I've been here for 22 years. I teach a variety of courses to undergrads and graduate students, and I also get to do research. And past 5 years or so, I've been doing some administration as well. So my research group looks at contamination of water. And so that's kind of our broad goal. We work on a variety of different projects involving chemicals, contaminants, and water supplies. So these pictures show my group. These are students that have been around in the past year or two, and I like to show them in the field doing their research because that's where they're happiest. So our research involves field work, lab experiments, and computer modeling. So the pictures on the left side show us in the field, and the bottom left picture shows us doing work during the pandemic. So it did slow us down a little bit, but we were still able to do field work, which was terrific. The middle two slides show students in the lab. We do a variety of different lab instruments. We use techniques from other fields. I do work in anaerobic microbiology. I do some work in nanoscience, and both of these are in collaboration with other scientists. And then the right-hand picture shows some results from computer modeling, which we use to predict future scenarios. And it allows us to see what might happen to a contaminant if we were to treat it a certain way. So I just wanted to talk about a couple of examples of research. This first example was from the Dan River coal ash spill, which some of you might remember. It seemed like it was just a few years ago, but it was actually in 2014. And after that coal ash spill, which happened in the Dan River again, this was in south of Martinsville in Eden, North Carolina. And this was at a power plant that used to be a coal-fired power plant. And they had stored quite a bit of coal ash next to the plant, which was adjacent to the Dan River. And you can see those ash basins in the picture on the left. Underneath that primary ash basin, there was a culvert that failed, and it released a lot of coal ash into the Dan River. And that's what the pictures on the right show, that grayish material in contrast to the brown material. The brown material is just the natural river sediment, and the grayish material is the coal ash. So we were able to get some funding from the National Science Foundation to examine how metals get released from coal ash into rivers. So the way that we approached this problem was to first collect samples. So that was part of our field work. And you can see pictures on the left showing me at the top in a kayak, in a canoe, I'm sorry, going down the Dan River, collecting samples. And then an undergrad who worked with me had a shovel and a bucket and collected samples that way. So some of our sampling techniques are pretty basic, but the goal is to collect good samples that we can bring back to the lab. And in the middle shows pictures of our density separation method. So what we were trying to do here was separate the ash from the river sediment. And that filter picture at the bottom shows the concentrated coal ash that we have separated from the river sediment. And then the picture at the right shows a grad student, Rui Saramaya, looking at that coal ash using a type of microscopy called scanning electron microscopy, so we can see close-up pictures. So I wanted to show some pictures up close and personal of coal ash. I think these are really interesting visually, and they tell us a lot about how the coal ash behaves in the river environment. So the picture on the left just shows what's called a cenosphere. It's just a hollow sphere that's made of aluminosilicate that's amorphous. And it's broken and you can see that it's hollow inside. There's a scale bar at the bottom that you might not be able to see very well, but it's 50 microns. So it's a very, very tiny little hollow ball. The picture in the middle shows also another cenosphere, but this one is coated with iron. And iron is well known to attract trace elements like arsenic, which is something I'm particularly interested in. And so we took a closer look at that iron-rich coating to see what kinds of trace elements were there. And on the right-hand side shows a piece of char, which is basically the leftover of the coal once it's been burned. And you can see there's a lot of pore spaces. There's lots of little spheres in there, lots of iron-rich coating. So it's a very complicated type of material. And our next process was to go even further into the nano world. And this was really interesting to go in and look at these tiny, tiny particles. This one in the picture is 200 nanometers across. So it's just incredibly small. And we're able to not only visualize these particles, but we're able to do chemical analysis of it. So this particular particle contains quite a bit of iron, which, as I said before, attracts trace elements. And it also contained trace concentrations of lead. And lead is a well-known trace element in coal ash, and something that we were very interested to learn, that it was transported with coal ash down the Dan River after the coal ash spill. So this next example, I'm going to show this to you more conceptually. And this has to do with work that we do in drinking water reservoirs. So these are important water sources for all of us who have drinking water on a public water supply. Some of us have our own wells, but many of us drink water from these surface reservoirs, and they're operated by water authorities who are charged with making sure that that water stays clean. One of the challenges of working in reservoirs is that there's often naturally occurring minerals that can be released to water and cause water quality problems. So in this example, we're looking at a cross section through a reservoir, and there's lots of oxygen in this water, and there's a happy fish in the middle. And at the bottom, you can see in the sediments, there are metal oxides. So for example, manganese and iron oxides, and they are stable in that bottom sediment as long as there's oxygen in the water above. But what happens during the summer months is that the sun heats up the water surface, which causes a thermal and density stratification of the water. And so that leads to a multi-layered reservoir system where we have the top waters called the epilimnion, and the bottom water is called the hypolimnion, and it's separated by something called the thermocline. And as this starts to separate, the hypolimnion becomes detached from the atmosphere. It becomes isolated from the atmosphere. And microbes will start to deplete the oxygen as they are, chewing up and eating organic matter. They will deplete the oxygen. So when the oxygen gets depleted in the hypolimnion and there's no replenishment of that oxygen from the atmosphere, those metals that were once stable in the sediment will actually be microbially reduced to a soluble form of metal that's then released to the water column. So under these conditions where we have no oxygen in the hypolimnion, we can end up with high concentrations of metals in the water. And so what we do in coordination with water authorities is we operate hypolimnetic oxygenation systems, meaning we pump oxygen into the bottom waters. And the goal is to promote oxidation of the metals and basically take them out of the water column. So after that oxygen enters the hypolimnion, we have nice, lots of oxygen in the hypolimnion. There's a nice happy fish, and the metals actually oxidize and drop out of the water column back into the sediment. So this type of treatment process is something that we study the whole cycle of the metals, and we look at all of the different processes that affect metals with the goal of trying to prevent the hypolimnion or the drinking water from becoming contaminated with metals. So one thing I'll say about my work is that we get to do a lot of fun field work and we get to travel to really beautiful places. I've had the opportunity to travel to Thailand to do field work there. I've gotten to work in beautiful locations and rivers and lakes and reservoirs. I also get to look at rocks, which makes me happy. So this job has a lot of fun aspects to it. So I will also say that collaboration with students and with other scientists is really critical for our research. So I have a couple pictures here of different research groups that I work with on campus as well as around the United States. And in these pictures, most of the people in these pictures are students. And I will say that most of the work that I do is in collaboration with students or with other scientists. There's very few things that I just do on my own. So if there are students who are interested in geology and or hydrology, there are just some ideas that I had for good backgrounds or skills to develop. One is working on field observations. So really just going outside and looking around, going on field trips and just spending time outside, I think, leads to the ability to make field observations. Thinking in 3 dimensions is a helpful skill, especially as a geologist. Writing is an important skill, and I know sometimes students going into science don't necessarily think that writing's important, but that's how we communicate our science is through writing. So that's something we work on a lot at Virginia Tech, as well as other forms of communication, oral communication, and data communication. Our students really in geosciences rely on a broad background in other core sciences like biology, chemistry, and physics. And they do need a strong background in math, statistics, and we teach them coding in our program, but it's always helpful to get experience in coding. And one requirement really for geoscience students is to learn GIS, because that's really the way that we basically visualize all of our data is in geographic information systems. So for supporting students to gain experiences in this area, I would encourage students to participate in informal education programs through 4-H, through museums. We have a wonderful Museum of Geosciences here at Virginia Tech. Any opportunities to volunteer for any kind of outdoor projects or science projects. Coming to the Virginia Science Festival allows students to see the breadth of science that and all the exciting things that scientists get to do. Participation in research projects or in science fairs is always a wonderful experience for students. Connections with local universities, and really I think for students in our program, the students that I think are most successful are the ones that are curious about the world. So I would say encouraging that curiosity is one of the main things that I try to do as a teacher at Virginia Tech. So yeah, so thank you for listening, and please feel free to reach out with any questions. My name and my email address are located here. Thank you.
Awesome. Thank you so much. If we were in person, we'd all clap for you, which is normally what we all do.
Thank you.
But I'll clap for you by myself instead. Otherwise, I feel like it's awkward, right? We do have some questions, and I'll probably build off of some of these questions as well. So you mentioned GIS, right? And I guess, so I actually went to a university that was huge in geography, and GIS is one of their big claims, is that they do GIS there. And I guess, so one of the questions we have here is, do you know some resources for students, or I guess I would imagine teachers too, to learn about GIS on their using?
Yeah, that's a great question. So I will say that honestly, especially during the pandemic, there's a lot of stuff that I've just done through Coursera or just online free courses that, and I did something through edX on data science during the pandemic. It's always hard to do something like that because, there's no grades or anything. So it's sort of self-motivated. I also took a philosophy class that I didn't realize was going to be so hard. So I didn't actually I didn't get very far in the philosophy one, but I did a better job with the data science, and I was able to learn some R programming along the way. So I would recommend that just as a way to get a flavor of GIS. At a place like Virginia Tech, in our geosciences program, we actually require students to take GIS because we hear from employers how important it is for the students to have that background. So we don't even let them have the choice, we just make them take it.
And I guess, so what kind of data are you using GIS to visualize?
So we use GIS for a lot of things, just even mapping. So putting topographic maps in GIS in the field so we can map rocks and be able to know where the rocks are located. We use also GIS for looking at and hydrology. We use it for predicting the direction of water flow. And we can use it to outline watersheds in a way that is much more accurate than just using a standard topographic map. And in the industry, even just making maps in GIS, even just simple location maps is a really important skill to have. So it can vary from something very simple like making a map to super complicated equations and calculations.
Awesome, thank you. And then so another question we have here is, how do you find so you talked about a couple of projects you work on, how do those projects come to you?
Yeah, that's a great question. So sometimes it's me, going out and making, writing a grant proposal on something that I'm interested in. Sometimes I've gotten some projects where I have a collaborator who says, hey, do you want to work on this project? The Dan River project, actually, someone from Cornell reached out to me, and that person was interested in working. They heard about the Dan River coal ash spill and reached out to me and said, hey, are you working on this? And I said, no. And he said, well, do you want to write a grant proposal with me? I said, sure. So, I got involved through the Dan River through someone from upstate New York. So it really depends. Some of it is initiated by me. Sometimes people come to me with ideas and projects. So that's why it's really fun. I've said no to some things that I'm not interested in, or I don't really have the expertise to help with. So, that sometimes happens too, where I maybe don't really see how I can get involved. But for the most part, I'm pretty open and receptive when someone comes to me with an idea.
Okay, and then only because you didn't touch on this, but what are the outcomes? What kind of what happens with the research and work that you've done?
So of course we're academics, so that we publish our work. So that's the thing that I'm supposed to do when I get grant money is train students and publish my work. So for the most part, we try to have as many peer-reviewed publications as we can from projects, because that's how we're kind of evaluated. But also sometimes our work is helpful for water managers. So for example, there may be problems that people have with a certain type of contamination, and we've been able to help them avoid that contamination, or figure out a way to treat the water in such a way so that the water contamination is remediated. So our work has both kind of academic impacts, and it does also have some practical impacts.
Yeah, actually, we had a presenter one time who was talking about, I think it was adding limestone to reservoirs, and he was working at a JMU, just north of you. So, and to keep, I forget what he was doing that for, but it was just really interesting. He was like, "Oh yeah, no, it's this whole thing you have to do with like limestone in reservoirs and rivers to make sure that the pH is correct, so that way things can live." And then all of these other like cascading things that happen. He was just like, we just get reports on like when it needs to happen, and we have a pretty good record of like the timing of when we the last time we added limestone, and when we might need to do that again, based on whatever.
Yeah, that's for treating. I bet it's for treating acid mine drainage, because I worked on a project a couple years ago on that, where we added limestone to treat acid mine drainage, and it was a really interesting project. Again, really practical results.
I guess so, like, and I don't know if you know this because you're more on the like hydrology, geology side, but when we're how long does it take for like native species populations to come back from some of these spills, or if there's minerals, like in the example that you shared?
Yeah, that's a great question. Since I'm not a biologist, I'd have trouble answering that. I know that some species are actually quite contaminant tolerant, which is a little scary, but there are some organisms that just have figured out how to live in certain environments. And I've worked at sites with really high arsenic concentrations, and I will say that the macro invertebrates get wiped out, but the bacteria, they figure it out. They know, the bacteria know how to process the contaminants. And in fact, they can thrive in contaminated environments. I think for something like the coal ash situation, I think it was initially, there were problems just because of the number of particles in the river, and that, gets into fish gills, and it causes problems with, ecosystems. But as soon as the ash settles out, I think it's more of the long-term impact of, organisms that will burrow down in the sediment. And if you have these trace elements like lead and arsenic in the sediment, is that going to impact growth? So other people have worked on those kinds of projects, and I've just, kind of been on the periphery of that.
And actually, so one more question, and it's a personal interest question of mine. So I have a lot of family in the State College area of Pennsylvania. And they actually, there's been, from what I understand, they don't dredge any of their rivers because the thought is that it's too expensive to kind of disrupt all of the sediment that's down there, and it's since been papered over by other sediment. And so in an effort, they're more concerned about disrupting any of the sediments that are up there. And that being more ecologically damaging than just letting it lie, because one, it's expensive. This is all the things that I've heard, and because I guess it's expensive, and they're just really, some people don't do a great job of stuff like that. So I don't know if you had any thoughts about that.
Yeah, that's really interesting. It's funny because, not funny, but in the Dan River, they did have to dredge in locations where the coal ash had accumulated. So, and actually we were there, this was down in Danville, and we got to actually go sample while they were dredging. And what they did is they tried to find the places where a lot of coal ash would accumulate and then dredge. And I think that type of treatment is, there's always a balance between, is it what's the cost and benefit of dredging and removing this versus just letting it sit there? And I think it really depends on the situation. If you have something like coal ash, over time that might cause disruptions with organisms who live down in the sediment, but during the dredging process, you're certainly releasing a lot of particles to the stream, and that also impacts the ecosystem. So there is that cost benefit.
Awesome. I think those are all the questions, unless anyone else has any, and I'm not seeing any. So thank you so much for presenting. And so with that, Jonas, you can take it away. It's all you.
All right. Well, hi, everybody. Thanks for having me. My name is Jonas, and I now run Aura Cacao out in Graydon, California. I went to RSI when I was a teenager, which was a totally transformative experience to meet other students like-minded and get to do a deep dive in, university level research. At the time, I did a project on power generation from vibrations using piezoelectronic technology. So kind of in the same way that you would power a piezoelectric wafer to generate vibration, running it backwards to actually power a harvest. Mostly for use for like micro sensor systems that use very, very small amounts of power. We were interested in energy harvesting so that a sensor system could operate somewhere autonomously without the need for batteries. So really cool project. And that was in line. So I went to Stanford University for that for my undergrad and my master's, which both of them I did in mechanical engineering. I developed, by my sophomore year, I developed an interest in green building and energy systems. So did a lot on campus with all aspects of green building design, also went into public policy and like, looking at working with the California Energy Commission and ways to decouple incentives for utilities to just sell more power, because just selling more electricity is not the right kind of signal that we want to send for utilities when we're facing global warming. We actually want to encourage energy efficiency. And so looking at how to send different price signals. There's been a lot of crossover for me in between like the engineering side of things and having the tool set to create technical solutions, but also realizing that so many of the challenges we're facing in the energy sector are far beyond the engineering side. And it's so necessary to cross over into the public policy side and into just like the human systems side of things. And so something that I think has always come into use for me is an ability to translate and understand complex technical problems and then present it to lay people and policymakers and other collaborators, so that we could come up with good solutions and a lot of team building as well. So I was in that green building world for a few years, and then came across a topic that I had never considered. By my senior year, got to do a senior design project in, what was it? So it was, I had actually gotten, a friend and I had gotten an EPA grant for green buildings. And the project didn't move forward as fast as the grant was requiring us to spend the funding because of some university constraints on their construction budget. And so we had to come up with creative ways to spend the money. And we're like, well, let's learn about green building in as many ways as we can. And I ended up traveling to Seattle, Washington, to go to a conference on stove and cooking technology. But it was cooking technology for developing world countries. And it was my first, and it was kind of a whole group of many people, not actually with very much scientific background, but who had spent a lot of time traveling to developing world areas and on kind of like international aid projects, and seeing that so many people were struggling with actually sustainable sources of fuel for cooking, and that there was a lot of deforestation resulting and such. And so they had set about with this mission of trying to build more energy efficient stoves. And a lot of the stoves were really bad because they had very little scientific background. And we were kind of there and we're like, wow, this is a fascinating project. These folks have had a lot of on the ground experience, but they're missing the technical aspect. So that really just like set my mind turning in a whole new direction of how can we use clean energy, renewable technology to benefit folks who are energy impoverished and actually are paying really, really high prices, for example, to even charge a cell phone battery, like 50 cents to charge your cell phone every time you charge your cell phone. We don't even think about it. We just plug it into the wall and take the power for granted. So that set a lot in motion for me. And I ended up joining that same friend that we had applied for the EPA grant with as an intern at a company called Potenko, which, if you've heard of the One Laptop Per Child project, that was a big initiative about 10, 15 years ago now. lots of money behind that project to get laptops to everybody. Interestingly, they didn't think about how they would power those laptops. So Potenko was founded to power those laptops. And we were looking at a variety of human power devices, initially bicycles, but also hand pull generators. So I spent a summer exploring ways to do low cost human power generation to power those laptops. Ultimately, the whole project failed because it turns out that this was kind of like a design solution proposed with very little understanding of what the actual need was. Turns out that people actually weren't needing laptops. They were already using their cell phones to gain access to the same information. And many of the laptops didn't even have cellular chips embedded, and that was the best way to get data, not by going to find a Wi-Fi hotspot somewhere. So interesting example of like an engineering solution, but not really connected to what the actual social problem was. So out of the failure of that, my friend regrouped, and he started a new company, Phoenix International, which I ended up working for on and off over the course of a few years while finishing my master's degree, which is basically a smart lead acid battery for entrepreneurs to charge in rural locations for running small businesses. And usually it was for charging people's cell phone charging businesses, and also running lights. And through that, basically improving access to education and clean energy. I left there and went to join another company, Greenlight Planet, which actually I have a little photo of the product, so I'll share my screen. Here we go. So this is what I ended up being on the design team for. These are solar lanterns, basically taking a consumer electronics approach to making micro solar systems. These units, for example, cost $10 to $20. So the idea was to get $10 to $20 lithium ion batteries, solar powered lights into people's hands. They're really high quality. I mean, I use these lamps to help replace kerosene. So again, providing people safer access to light and safer access to education. This is kind of where it all like really started working. I was like, oh wow, we're actually doing the need finding on the ground, talking to people what they actually need, and then designing a product specifically for them, rather than like, oh, we think you guys need a laptop, and oh yeah, we need to figure out a power system. Kind of, it started getting cohesive. This company has reached many millions of people. It's very effective. And I did not think I was going to leave this job, except that I became really passionate about chocolate. So I'm just gonna, let's see, how do I stop this shit? There we go. So my career took an unexpected turn. I was traveling in Oaxaca, Mexico, and learned chocolate making from an indigenous Zapotec elder named Maria. Hi. It's great to see you.
Long time since I've seen you. How's
Yeah,
business?
it's been so long.
Yeah. Oh, sorry, I'm on headphones. Why?
How is your business?
It's doing great. I'm having so much fun.
Anyway, so good we finally got him.
Joanne's just very excited that we finally got you
Yeah,
to present.
I'm so happy to be here. Yeah, so just diving into the good stuff about chocolate making. One of the things that I had realized at both of these companies was that, my success as an engineer was dependent on these larger organizations, the ability of the founders to fundraise, the ability of the marketing and sales team to get our products out there. I loved getting to do the engineering, and I was also fascinated by all the other parts of the picture that made it work. And so when I encountered chocolate making, it wasn't initially going to become a career for me. I spent about 2 years just learning how to take this experience of traditional chocolate making I'd had and bring it home, and just began doing DIY chocolate making at home as a hobby. Figuring out how to roast cacao beans, shell them, grind them, and temper and deposit them into chocolate bars. I became especially interested in healthy chocolate. So chocolate with very little sugar, like 85% and darker, 100% cacao, using coconut sugar as a sweetener, things like that. kind of reformulating the recipe so that it was something that I really felt good about eating every single day. Because it actually turns out chocolate is extraordinarily good for you as long as you go light on the sugar. And a lot of the research studies that have been done on cacao are starting to catch up with what those benefits are. But they're all usually done on very dark chocolate, not the traditional candy that you'll find in the supermarket. And when I started kind of taking this turn of making chocolate and talking about it as a healthy thing, people became really interested. And they're like, you should take these to the farmer's market and you should do this as a business. And eventually I was kind of like, you know what, maybe I should try. I kept a job part-time at Greenlight Planet for the first couple of years of doing that. And that helped me pay the bills of my ever increasing chocolate hobby. I was getting more machines. I bought my first sack of cacao beans, kept diving deeper into that. And again, the chocolate was really interesting because it was still linked to these communities in the developing world that had often very little access to resources. So, working with cacao farmers who have just a couple acres of farmland somewhere, and us buying from them was helping bring their cacao to market, and us paying good prices was really transforming their lives. So I saw the social impact that was possible with cacao, especially because so much of it is still based off of this, so much of the chocolate industry is largely unchanged from how it was several hundred years ago, which is this colonial exploitation of tropical goods and really no respect for the people or the land that were involved in growing it. So in many ways, I realized how backwards the chocolate industry still was, and that there is a lot of room for a whole new business model that's much more regenerative and positive for the earth and its people. So I kind of set about to combine my ability in engineering and all the tools to make chocolate making, and to scale a small scale chocolate enterprise into a large scale chocolate factory, and simultaneously build the business, the marketing, the sales, the financing, all of that to support that hobby and that engineering. And so I founded Firefly in 2014. So we're 8 years, this May will be 8 years in as a business. We just renamed to Aura Cacao last November. And excitingly, we just moved. So now I moved out of a 2,000 square foot facility into a 10,000 square foot facility. And we're in the process of building that out to a very modernized, largely automated chocolate factory here in the heart of Sonoma County, which is wine country. If any of you are familiar with wine, you've probably had Sonoma County wine, and we actually are in a property that is part of a former winery and used to be used for aging wine barrels. And so we have a lot of big equipment in here, and I'll show you a little bit of what we're working with and show you how I'm applying some of my engineering skills with that, because practically every machine I've taken apart completely, I've hacked it in some form, I've fixed the electronics, I've programmed it, I've made a lot of mechanical changes. I'll also show you some of the iterations. So this is just a quick video taking you to a cacao farm and the community in Guatemala that we sourced from, to give you some of like the reason and the backstory of like why all the other stuff. That's a cacao pot being opened, the fresh cacao fruit. That's cacao being roasted the traditional way. There is being hand cracked into cacao paste using an inking tool, and that's a liquid cacao drink. Most people drink it down there rather than so that's just a snapshot of like where I go on my travels, and the communities that the cacao comes from. Now let's go to where should we go? Let's go to the space. Shoot, I was hoping I could just share my entire screen. I wonder why I can't do that. Share screen. What if I share the whiteboard? Does the whiteboard show everything? No, I have to open it all up first. Okay, well then, that is a little different flow. 1 second while I pull up these photos. Okay. open everything up. So now we are in this building that I was saying is built in 1947 and originally just a warehouse. So we are hard at work turning it into a chocolate production facility. So, oh man, I might have to, okay. Shoot, I've never had this problem before where I can't just share my whole screen. What are you guys seeing right now?
The front of a building.
Okay, you are seeing a building. Great.
Yes.
Okay, so that's the building we're in, Hallberg Hall. And we are kind of off in the back of that. Let's see. Okay, every image is going to make me share it individually. I should have put these in the PowerPoint. Okay, I'm trying to think what the best way is to do this now because I have a lot of different images. Is there a way I can condense this into a slideshow? Oh, Zoom. Well, okay, I'll just pick one or I'll just pick a few images to share rather than all of them. This is the inside of the building that we're building out. You can kind of see that's right. Are you seeing it like a big hall with an arch? Okay, so that's what we're building out. Okay, you saw that one instead. Okay, great. And well, so challenges. So you know, we're basically taking that traditional process that you saw of roasting the beans and shelling them and grinding them into an industrial scale. So one of the machines that I'm working on right now, which has been pretty exciting, has been a chocolate winnower. So this is a machine that is shelling cacao beans. And I'm just going to open a few videos. And so it breaks the cacao beans into pieces and then, this is so tricky to share. Okay. So where is it? Okay, I'll share this video real quick. So here you can see out of a big hopper. We had just roasted all these beans. And these are entering a cracker. So basically the idea of the cracker is it lightly shears the beans so that the shell and the inside of the beans separate. And then what we want to accomplish from there is we want to get cacao nibs out of it. So now you'll see this video of the cacao nibs. The way that it's separating out the shell is by airflow. The shell is really light. So basically there's like 5 different sized tips and it's going down smaller and smaller pieces. And then once it's all the same size particle, it's pulling the light shell out and the heavier nib stays. And so we're trying to get really good yield on the process, right? Because you don't want to suck up any small pieces of cacao nib because that's lost cacao that could be used in product. And you don't want any shell in your nib stream because that's not what chocolate is. It's actually the inside of the bean. So that is, the cool thing about this is that this is a machine that was built in 1968 in Germany. And we actually bought it from an old Hershey's plant in Illinois and have been restoring it. We built a completely new control system for it and have just been getting it up and running. And it's such a good mechanical design that they're actually still building and selling the same design, the same company is. So you can still buy it today. But it's been just really fun to restore this machine, and I'll give you a picture of what the whole machine looks like so you have a visual. There it is. So you can see it's tall. These are 20-foot tall ceilings. That's the forklift in the corners there is holding the hopper full of roasted cacao beans over it because we don't have our automated system yet for feeding it. And then all those levers on the side of it, they control the airflow, and we have variable speed drives on the exhaust air here and on the vibration and on the cracker and such. So there's a lot of a lot of the engineering that ends up going into chocolate making, you know, is these very complex systems that we're trying to reach a steady state in, right? We're feeding the cacao beans in, and any change in the input, even with like different beans, requires slight adjustments to all the settings. So we're constantly trying to produce the optimum results while the whole system's in moving. So there's a lot to do with control laws and just understanding how all the variables impact each other and controlling variables just to make sure that we can consistently create good product. Where this takes us ultimately is to our chocolate chips. So a lot of the market for 100% cacao is originally sold in just these big blocks of chocolate, and people who are interested in making drinks, they actually had to chop up these blocks of chocolate and then put them in hot water. And I realized that chocolate chips would be much more usable. But scaling up from, there's actually like practically no small scale chocolate chip manufacturing tools out there. So I had to build my own. And then now finally we've gotten to a scale where we can afford a large scale chocolate chip making machine. But both of those, like the small scale and the large scale, is very unique in the marketplace. So it's kind of given us a niche in the industry. And there's practically nobody making chocolate chips from the bean in the way we are. There's a lot of actually producers, but they're often melting down bulk chocolate produced by very, very large producers of chocolate. So for us to be roasting the beans, shelling, and then producing chips from them is actually pretty unique in the marketplace. And we mostly do it direct to consumer. So we make our products all in-house, and then we send it directly to people who buy it through our website. So that's kind of the model we're working off. I'll show you the chocolate chips machine because that's really fun. Okay, let me pull that. I'll show you the first generation chocolate chips machine, and then where it's gone since. Okay, cool. So there's one video, there's another video. Okay. So this is what it started off as. This was my very first prototype, just to see if I could produce chocolate chips at all, like what that could potentially look like. So I have this pipe of tempered chocolate. I'm trying to find the video so I can play it. Let me close that out. I have this pipe of tempered chocolate coming out, and I just had a local machine shop drill a bunch of holes into it to see if I could then use a piston actuated on a timer to deposit chocolate onto a moving belt. So this is a video of that. And you can see, there it is. We're producing chocolate chips. This only lasted for about 5 minutes before the pipe froze up, though. So I realized that doing this without a hot water jacketed pipe or a heating element on it wouldn't go for very long. So I'll show you kind of the many prototypes later of that version. We have this thing where ended up creating this whole head with nozzles. These are actually plastic injection molding nozzles that I ended up using. You can see the heat tape on it, and there's a whole row of them now. It's doing a pretty good job depositing the chips. You can also see the controller pauses the belt so that while it's depositing it, so that we don't form cables, and then it moves along. You can see the consistency of the chocolate. I'll play it again. It has to be just right so that it separates from the chip and doesn't leave like a long drip mark. So there's a surprising amount of variables here, but we were able to make it work. And I'll show you at the time, the end product. Here it is. This is the finished chocolate chips rolling off the end of our belt there.
So is this going on?
And didn't realize that somebody's talking on that, but yeah, this was our homemade effort at building chips. And for several years, we ran all of our production on this. It was a headache to get the chips line up and running, but we always managed to pull it off and would produce 1,000 pounds in the course of a day and then have chips to sell. Now, we are in a building that has a professional chips line, and I'm trying to find, let's see, where is it? That is here. This machine is really exciting. It's totally mesmerizing to watch. It uses really cool technology that's actually just come to the market called a roller depositor, which is a continuous style of chips. So you'll notice the chips depositing. So you'll notice that the belt never actually constantly feeding chocolate through this roller, and then it comes out through this little hole. Quite a good job. That's an early test video, but it actually makes very uniform chips. And I'll give you 2 more views of that. Here's kind of a top view of the chips in production. There they are going down the line, and they're basically going into a 100-foot long cooling tunnel. That by the time they reach the end of that tunnel, they are fully solidified as chocolate chips. And so here is the end of that belt. And the chips, really nice chips peeling off. Right now there we're collecting them in boxes, but now they're actually going onto a conveyor, which feeds a big tote that can hold like 1,500 pounds of chips. So that is, my intention with showing you all those videos is to kind of give you a sense of the iterative process that we've been through, and how much each step of the process we've had to like experiment and fail and put together all the different components. And that has ultimately given us like the know-how of like what machine to buy on a larger scale, so that we can make the right decision and not like make the mistake of buying a machine that then doesn't work quite like we wanted to. Like we really built the experience that then let us purchase the right equipment at the scale. And, and then that lets us be a more efficient and lean startup, because we're not making big mistakes. We're completely self-funded, so we haven't taken outside investment to grow the company. And so everything has had to come from our sales and from our experience. And it's been really fun building all of our own chocolate making machines. And it's also really nice now to go to larger machines that are built with the kind of volume that we're working with in mind and aren't failing in unexpected ways. And now, we have procedures for maintenance and having the right backup parts and such in place. So yeah, my world is very machinery heavy now, as we're bringing on all these new tools to work with Cacao on scale to ultimately support that core mission of supporting the farmers and getting healthy chocolate to people. There is a ton of really fun math problems and engineering along the way. I actually want to build a kind of book of chocolate making math problems. If that's something that people are interested in, definitely let me know. But I'm constantly, a lot of it is like volumetric and flow rate related. We have, so those nibs, they get fed into these grinders, where there's actually some pretty cool chemistry going on as well in the flavor development process of chocolate. And then once those grinders are done, they get pumped through a chocolate pipeline into these big tanks, and then they go through the tempering machine into that chips depositor. So there's a lot of number crunching in terms of how long does it take to fill the tank, how much energy input do we need to put into the water jacketed pipeline to keep it at a steady state. A lot of neat control problems. So yeah, it's none of it is often as rigorous as the kind of engineering that I used to do in school, getting my master's degree. I was building robots and designing circuit boards and things like that. But it is still constantly needing my expertise, and it's very empowering to like go into the electrical cabinet of any of our machines and be able to take apart, look at the part number, look at the circuit board. I like actually have a circuit board here on my desk from a machine that broke, and this circuit board, I'll give you as an example, it costs like $300 or $400 to replace. But with my benchtop tools, I was really quickly able to realize that it was actually just one of these relays that was broken. This relay cost like $2. So I ordered the relay from China, replaced the relay, and we just saved $400, as like really, really quick and easy example of something. And the chocolate making machinery is really expensive. You know, it's like super custom stuff in the food industry. And I actually source a lot of my chocolate making equipment in China because so with the solar companies, we were doing manufacturing of our solar products in China. So I spent like a year going to China 10 times and building all these relationships with factories and like learning how to work in the Chinese culture and such. And now we've bought the majority of our chocolate making equipment in China because it's like a third or the quarter of the price for much of the same stuff. You just have to be very, very specific about exactly what you want and how it needs to work. And, you know, Apple's produced in China. Apple computers. So it's not like you can't get quality out of China. You just need to know how to work with the engineers there to produce the tools that you then rely on. So yeah, the engineering has been a crucial part of being able to run the startup in a lean way and not need to take outside investment. And one of the reasons I've been so against taking outside investment for the company is having seen that at the two solar startups, how much autonomy you lose in terms of creative direction. You know, all of a sudden you're working with a whole team of investors and stuff that sometimes have different goals than what you do as a company founder. And I really like that autonomy. I'm just somebody who works really independently, loves working with other people who work independently. And so having that freedom that has kind of come through our ability to really keep the engineering know-how in-house and keep ourselves lean as a result has been essential. We're actually ending up doing a lot of construction at our facility as well. We've been going through this permitting process for the old building, and it can be really expensive to get some of this stuff contracted out and built. And, you know, many times our approach has been to find a contractor that's willing to teach us and teach us how to like run electrical to all of our machines and then sign off on the work, rather than paying them to do all of it, where we're paying somebody, you know, $150 an hour just to pull some wire through a tube. Like, we could do that too. And along the way, we get to do all the math on like, well, how many wires can we run through the code, through the tube per the electrical code? And, you know, what's the amperage that we can run through a certain wire and such. And then we know inside and out how the whole chocolate factory is built, which in the end is really fun and really empowering. So I really love that freedom and the to take everything apart and do everything ourselves that engineering has given us. And then, you know, again, translating that out into the world has been like the marketing and the sales part, and learning all those pieces of business. I would say those have been the most challenging, actually, because I had zero background in those and kind of had to realize I had to get good at those in order to keep my love for tinkering with machines going and working with ever increasing sizes of cacao. So that's kind of the real fast version of what we're up to here. Feel free to ask me some questions, and I'm sure more stories will come out.
Yeah, actually, so I personally was very interested. My dad actually did a stint as the quality manager for a high-end chocolatier in Vermont.
Oh, nice.
So, you know, to throw some shade, I mean, I don't mean to really throw that much shade on other chocolate companies, but the man didn't eat like Ghirardelli chocolate. He thought it was, you know, he put that in the same category as Hershey.
Absolutely.
Because according to him, if you put vegetable oil in your chocolate, it's not worth eating.
That's one of the fun things about being in food, is like food is an art form, right? Like there's all this engineering that's going into supporting how we make chocolate, but ultimately transforming a cacao bean into finished chocolate. There's so much chemistry, so many variables that, you know, we're just doing our very best to have a repeatable process that we can rely on, and so that then the art form of it can arise, and we can really tune into like, okay, should we volatilize some of the acids that are coming off of the cacao bean for another hour? Will it taste better then? You know, and this very iterative experimental process there. And you have to be opinionated in what you like too. You just, you know, everybody kind of decides, well, this is the best chocolate, you know, this is what we want to offer. And then we look at the reviews and we see how people like it and get that kind of feedback. But yeah, the food world is fascinating.
Yeah, he also never found a yogurt he actually enjoyed. So he had to mix yogurts to make his own because that was the flavor profile he was looking for. And I mean, I also would imagine too that you have a really good sense of taste and a really sensitive palate in order to be able to taste the differences between, you know, that you're trying to figure out where off flavors are coming from. You know, is this the flavor profile we're looking for?
Yeah, that's something I've had to train myself. And that's, you know, a key part of entrepreneurship is surrounding yourself with the people who have skills that you don't. So one of my good friends is a professional chef, and we would constantly do chocolate tastings, and he would tell me like what he was tasting, and I'd learn to, you know, you have to develop a vocabulary for describing what you're tasting so you can talk about it with other people and you can troubleshoot it. You know, it's like, where is that particular flavor coming from? Let me just turn that up. Ring, ring. Okay, yeah, so that's actually, I would say, not something I was good at all and have had to get good at. And now it's actually part of our staff training, you know, because nobody really walks in the door with a developed palate for tasting cacao. You know, like we have to taste the cacao in the roasting and decide, oh, is that going to make a good chocolate, or do we need to change the roast profile? So you kind of even have to learn how the flavors transform over time and across processes.
Yeah, no, I know. I also know people who work in the beer industry, and they can tell you exactly where the problem is in terms of is it in the draft of the beer, or is it a production issue when they taste an off flavor, which I think is wild. They're like, oh yeah, no, this is definitely a water quality issue, and I'm like, I don't even understand how you know. And versus, you know, to me, because it tastes the same, because they should be different ones, and I'm just like, yeah, those two things taste the same. Dirty draft lines versus, you know, yeah, water quality issues. And they're like, no, they're very different flavors. And I'm like, okay, I trust you. I'm not seeing it right now.
Yep. One of the things I've had to learn is to not stress out about it too much, you know, because we're geeking out and nitpicking every detail of the flavor profile. And then I give it to somebody else and they're like, this is amazing. And we're like, okay, yeah, great. You know, and it's not that it isn't objectively great. It's just you can drive yourself crazy with all the nuances of it. And, you know, to get a batch 100% right, like, you know, that's something that you work to over a lifetime. You know, it's and over many years of experience, and it becomes a whole team effort. And in the meantime, the subtle details that I'm nitpicking in order to improve our process, nobody else notices. Like they're so subtle, it's really good chocolate. So there's, again, it comes to that art and kind of balancing all the variables that are happening.
So actually, where do you get most of your cacao beans from?
I source from Belize, Guatemala, Colombia, Tanzania, Uganda, and India currently.
Okay.
Yeah, and each of those is a beautiful relationship in and of its own. We've learned a lot from each of the different countries that we've worked with and our suppliers there.
Awesome. No, I was curious, sorry, because we did have an event a couple of weeks ago with the cocoa bean sourcer for Hershey, and he was talking about where beans are coming from for them.
We kind of, what I would say is most interesting about our supply chain is that we're not buying through the commodity market. We actually buy direct from suppliers, and we've just found that we're able to get much higher quality and give much better prices to our suppliers by circumventing the commodity market.
Yeah, and I'm sure, you know, and that does, you know, as someone who's done work with refugees and immigrants myself, I mean, I'm sure that does a huge amount in terms of local economy, you know, and that really perpetuating kind of improved educational outcomes and like opportunity. And there's so much of that goes, you know, just kind of, because that's how those communities work, right? Is that that extra money that they're getting, they put right back into their neighbors, their family, and, you know, everyone around them.
Yeah. Yeah, it goes a lot to tropical ecosystem preservation too, because cacao is an agroforestry crop that can be grown in intact protected rainforest. And so giving people right livelihood to not need to destroy the rainforest through kind of the traditional avenues of cutting down timber or ranching cattle or mining is, you know, we need practical economic alternatives that give people right livelihood to incentivize rainforest production. And that's what cacao can do, which is really cool.
Yeah, so I now have a lot of thoughts about the geopolitics of that as well, but we won't get into that because that's what I think that I feel like there's a whole other conversation.
It's a rabbit hole.
Probably.
Yeah.
Yes, rabbit hole conversations I have. And then, so you mentioned sort of like tempering chocolate. And so like, I mean, I know some about this, but there's a question, like, can you talk more about tempering chocolate?
Sure, I totally skipped over that. The science of it is fascinating. You can think of chocolate, like just as an analogy, think of water, right? Water goes from liquid and then it becomes solid and then forms ice crystals along the way. Think of tempering. So chocolate naturally has 5 different types of ice crystals that it'll form as it solidifies. And the cool thing is those crystals, you know, freezing doesn't happen. It doesn't go from solid to liquid in an instant. It's a gradual process. So you actually have liquid chocolate with seed crystals that are beginning to form, but because you're still circulating it and applying the heat, it's not solidifying. And so tempering is this process, you know, chocolate solidifies at like 85, 80 degrees Fahrenheit. Actually, it's a little lower than that. But it's beginning to solidify at that point. So we're like teetering right on the edge of the chocolate becoming solid in the pipes, which is not fun for us when it solidifies, but we're like basically trying to get it to be ready to set up so that when we put it on that belt, it'll solidify quickly enough by the time it gets to the end of the pipeline. You can think of tempering as a process of seeding the liquid chocolate with the right kind of crystal that we want. We want the type 5 crystal, which actually has the highest melting point. And then that one actually sets up, it solidifies the fastest, and then it's the most melt resistant, and gives it that crack and that shine. So basically the tempering process is we're bringing the temperature of the liquid chocolate down to seed it with the type 5 crystal. You can actually think of it, you bring it down and you create all the different types of crystals, 1 to 5, and then you melt off the lowest temperature crystals so that you have liquid chocolate just with the type 5 seed crystal. And then you maintain it at the perfect temperature to not knock it out of temper by the time it's getting to that belt. And then you cool it at the right pace. So the cooling is actually a critical part of the tempering process as well. And that's how you get that chocolate bar with the shine and the snap. And if you've ever had a chocolate that's melted, like left it out in the sun or something, and then it's re-solidified and it gets all these different colors, you're having cacao butter bloom coming to the surface there, and you're having different types of crystals forming, because at that point it's an uncontrolled solidification process. And so tempering is basically a controlled solidification of liquid chocolate into hard chocolate.
So you talked a lot about sort of how engineering has helped you. And so I'm going to change one of the questions a little bit. So in a much broader sense, what would you say are kind of like the biggest STEM skills that you have found to be most valuable and transferable as you've gone along your career journey? I
mean, on the really broad, like the way I look at engineering is that the discipline is far too large for any one person to ever learn all the different fields of engineering in a lifetime, right? So instead, they teach you to be tremendously resourceful and to dive into a new field of engineering and learn how to solve problems in it really quickly. So it's that resource, it's like that ability to tackle problems and learn how to solve problems very quickly. Just like I didn't learn anything about chocolate making in school, and nor were there very many manuals on chocolate making, but dove into this, began talking to people who knew stuff, began visiting chocolate factories, began getting tools in the door, began reading through every single manual, get the data sheet for the controller that's inside one of the cabinets, read that whole thing, figure out how to reprogram it to get it to do what I want, just having that complete fluency with anything and that understanding of how the whole system fits together and being able to take it apart and tinker with any one aspect of it. Like, I feel like the engineering program gave me the confidence to go do that and take things apart. And, to get to that engineering program, it's all the math that goes into it, all the understanding of volume and flow rates and things like that, all the material science and things. So I I feel very fortunate to say that I get to use a lot of what I went to school for, even though I'm not in a like strictly engineering discipline.
No, I definitely feel that. I studied biochemistry for undergrad and had no idea what I was going to do with it. And now I get to work with teachers all the time on science things, which is really exciting. So I feel that immensely. And I guess actually, and this came up a lot in some presentations I hosted last week about kind of like what's the hardest math they have to do. Because I think, and there's this whole conversation we had about how, there's a huge push for like really, really hard math. And then I had two engineers last week who were like, oh yeah, no, the hardest math I'm ever going to do is like algebra. And so I thought that was really interesting. So what's the hardest math that you do?
We definitely have some like differential equations and integration that comes into play mostly in the roast profile, as we're basically trying to calculate well, we're doing a lot with rate of rise and momentum of a roast. You kind of think of roasting as like you're pushing on a gas pedal, but then the car doesn't stop when you let go of the gas pedal, it coasts. And so to control a roast, you really have to look at those differential rates, and then to calculate the total amount of heat that a cacao bean has seen over the time of that roast. You're basically integrating that roast curve. So that's probably the most complex we've seen. Aside from the math, I've actually also done a fair bit of computer programming for the company, mostly on the web side of things. So that's also been very useful.
Awesome. And I will do a last call for questions from our teachers. And I mean, honestly, I could probably talk to you forever, just because I have learned a fair amount of chocolate just from like, my dad's work with, because he did quality management. So he was doing a lot of the machine stuff, making sure the machines were doing things cleanly. And they were doing like chocolate products, so like truffles. And like little chocolate bars. And I think it's fascinating.
There's so many areas you can geek out on. Like now that we're transferring chocolate over larger distances, we have all these chocolate pipelines, right? And after you transfer the chocolate through them, there's chocolate left in the pipeline. How do you get it out without taking the entire pipeline apart? It turns out there's this like whole subfield of like process engineering where they have these things called pigs, which are plugs that they're like silicone plugs with washers, like basically like washers that you push through the pipelines with air pressure. And so it squeegees out the inside of the pipe and then shoots out the other end and gets all the chocolate out. So it's like the kind of thing you like are fascinated to discover. And these are the same things they use in like oil pipelines and in beer facilities and such. And you just like never even think that that's how they clean a chocolate pipeline, is by like sending this giant like silicone squeegee down it with air pressure. So we're constantly like learning new things.
And it's funny because you say that and I'm like, yeah, I mean, that makes perfect sense to me based on everything I know about, sort of food production and, using squeegees in other situations. So I used to actually work at a pool and we had to clean out everything every year, right? And so there's all sorts of weird squeegee stuff that you have to do. But yeah, no, that's so interesting.
And that, then goes back into like, okay, it improves our yield on a batch, because we have a certain amount of process loss, and then that then feeds back into the economics of the company. It all connects in such fascinating ways. That's what I really love about it.
Awesome. So there were no more questions. Just Dr. Schreiber, making sure we knew that. Oh, it sounds like Willy Wonka's Chocolate Factory. It's a fun comment.
They call me Jonas Wonka.
My friends used to call my dad Willy Wonka because I would bring giant like 5-pound boxes of just like seconds chocolates to college with me, and they're just like, what is this? So yeah, no, I'm glad it's not the only one.
Yeah, that's really cool that you've had that experience as well. Yeah, if anybody wants to be in touch, feel free. Jonas at oracacao.com. You can also follow us on Instagram at Cacao Ceremony, or search Ora Cacao, ORA Cacao online, and you'll find the website and things like that.